In this video, I'll introduce another idea. In this video, I'll introduce another algorithm for doing page replacement. This is going to be called OPR, or optimal page replacement. So here's the basic idea. When I want to pick a victim page, right, something to throw away, what I'll do is I'll pick the page that's not going to be used for the longest amount of time. Okay, it's a really simple rule. Maybe one thought is, why would we go with that? Why would we want to use it? Why would we want to basically say that the page we're going to throw out is the one we're not going to use for the longest amount of time? Why would that be good? Think about that for 1 second. So here you can think about it maybe on kind of from two sides. First of all, it's like, what happens if I throw out a page? It's going to be used, pretty soon. Would that be bad? Well, the answer is yeah, right? If I basically discard a page, it's going to be used, super soon. That means that I'm going to throw it out, and then I'm going to quickly have to bring it back in. That's kind of going to be problematic. So clearly, right, if I do things if I throw away pages that are kind of close to me, right, that's going to be a bad thing. Now, what about the opposite? What happens if I think about, basically throwing out a page, right, it's not going to be used for the longest amount of time? Well, that's good as well, because what happens is I have some flexibility, right? During that interval, right, between, when I'm going to, when I'm basically take out the page right now, right, and then when I'm later going to be bringing it back, that's sort of a gap that I can have other pages available in my little bit of a buffer, right? So it gives me more flexibility that I can be kind of able to choose more things, right, that maybe are going to be used. What you end up seeing is that whether you go to either side, right, kind of pulling it forward, going far away, basically what happens is, right, kind of the further this you are, right, basically it gives you more flexibility. You get more pages that are available for different reads, right, and kind of you'll get better performance. So this looks like a pretty decent approach. So let's try actually running this on a sample and see what we get. So over here, right, our sample sequence, we have obviously our kind of 3 starting page faults. These are going to be, always there. These are basically for a pure demand paging model. So yeah, let's start tracing this. So we have basically those first 3 handle. For the next one, 9, I'm going to be fine because it's already there. Then I look at 6, right? And so 6 is going to be a little bit of a different rule than before, right? We're going to have to spend a little bit more work on it. So if I get a 6 here, which is this over here, what happens is I need to look at what I have basically in my little buffer and pick which one is not going to be used for the most amount of time. And so I have to actually go through and kind of annotate this in my mind. So for example, here I look and see, okay, 7 is going to be used over here, 5 is going to be used over here, 9 isn't going to be used again, so I'll put it way over here. Well, because that's how things are set up, right? Basically, what I want to do is I want to discard the 9 because the 9 isn't going to be used for the longest amount of time. So that's the one that I'll end up replacing. And so my 9, right, goes away, and I get the 6 over here, right? So there's a page fault there, and the 9 gets replaced by a 6. So far so good. Then I have a 5, right? A 5, right? It's going to be fine because, well, hey, it's already there. That's going to be good. Then I get a 2, right? So my 2 runs, right? I need to basically look at the thing before and figure out who to discard, right? So if I'm, basically adding something new, right? That 2, I can look ahead and basically say, that's 7, right? 7 is going to be used over here. 5 and 6, right? Those are going to be used sometime in the far future. Probably not soon, so I can throw away one of those. In this case, because it doesn't really matter whether I throw away 5 or 6 because I don't need them again. So in this case, right, basically my 2 will go, it'll replace the 6 over here, right? And that causes a page fault. So there we go. All right, look at the next one, 7, right? 7's already there, right? So unlike previous algorithms like FIFO, 7 hasn't been cycled out. We've actually been keeping it around because we know we're going to need it at some point. So there's not a page fault there. Then we go to 4, right? 4 looks at these again, right, and tries to figure out, what comes next. Here, right, I have to basically look for, 7, 4, 5, and 2, right? But those, don't exist over here. So I can basically delete any one that I want. In this case, I'll get rid of 5. That is a page fault there. Then I get 1, same thing, right? I have to choose from those 3, right? Pick out 1, but there's nothing else in the future, so I can't really do anything. So there's another page fault over there. So yeah, we end up with a total of 7 page faults. So that's the basic idea of the algorithm, right? And typically, right, we're gonna get some pretty good performance. I know that right now it's not that much better than we saw in the previous example, just because in the previous example we had 8 page faults. Here's 7. I mean, this is better by 1, but usually it'll be a lot better, right? Just for this particular sequence, right? It's not so good. All right, so one question for you guys to think about for a second is, how hard would it be for this algorithm? How hard would it be So one question for you guys, how hard would it be to implement this algorithm? Think about that for just a second. So the answer to that is, simply put, it's impossible, okay? Because the problem is, it requires kind of forward knowledge, right? So you need to know, everything that happens in the future, right? So if I'm, here at this time, here, right? If I'm trying to pick out, what, frame do I evict, right? Who do I make a victim? That requires me to know about all the requests that happens in the future. And simply put, I can't have that, right? I don't know what's going to happen in the future, so I can't do it, right? So optimal page replacement, even though it is optimal, typically it's impossible to implement, right? The only time I can implement it is when I know the entire sequence already in advance, right? That's going to be when I can do it. Otherwise, it's a no-go.